2x minus 4y equals negative 12. Does anyone notice anything funny about these equations?
There's not.
They're doubled. Yeah, they're doubled, right? And multiplied by negative. So that would just mean that if we divide, let's say we divide this by negative 2, we would get x plus 2y equals 6, which is the exact same as that guy, right? We divided this whole thing.
Don't we usually multiply it though?
Yeah, you can. So you can like multiply this one and this one by negative 2. And it would be the exact same. Like, the big thing is like, they're the exact same equation. Okay, just factored. So if they're the exact same equation and we want to know what x is, does it have just one solution? Or does it have no solution? Or does it have many? One solution? No, not one solution, because it's the same line.
Is it gonna have many?
No solution?
Well, so it's kind of unique, but because it's on the same line, like let's say it just looks like that, then the other line is like literally right on top of it, okay? And so normally whenever you do problems like this, you're looking for like the intersection, like that's one point, you know? But because this is like the same exact line, and they're not parallel to each other, because parallel would mean that they'd never cross, right? So because they're the exact same line, they're gonna have infinite solutions.
So many solutions.
So many solutions. Yeah. Does that make sense? Yeah.
So would it be like that for example, if they're all doubled,
Mm-hmm.
then it would be many solutions?
Mm-hmm. Or if you get it and you realize that they're parallel lines, then they're never gonna have a solution.
Okay.
Okay? Yeah, so it's just E. Just E. It's 15, we're on 16. So we're going to use a calculator again, okay? So solve the system of 2x minus 3y equals negative 8, and then negative 3x plus y equals 5, and then negative x plus, or minus 2y equals negative 3. Okay? So normally we only have 2 equations that we're working with, but this one has 3. So that can be like a little bit confusing, but we're still gonna plug it in like we normally would. Okay, so you take all the coefficients. We have 2, negative 3, and then negative 3 and 1, and then negative 1 and negative 2 times x and y equals these guys. So negative 8, 5, and negative 3. Okay? So then whenever we do this, we're going to do A, X, B. Remember, it's going to be A inverse times B. So we're going to plug it in.
Will it always be that formula? Or
Mhm.
is it always?
Always.
Okay.
A inverse times B, where B is the answers. So we're going to go, do you want me to talk you through it again, or do you think you can do it?
I want to try it.
Talk you through it? Okay. So we're going to go to second, matrix, over to edit, and then, so we're going to go back to 1, all right? So we're going to say 1, and then we're going to change the dimensions up here from what they were. So what is the dimensions of this matrix?
3 by 2.
3 by 2, yes. So 3 by 2. All right, and then we're going to go through and add it, put in the numbers. All right, and then second quit, and then do the same for this one. And what's the dimensions of B? 3 by 1, yes. Alright, so once you have your second quit out of it, and then you're gonna go second matrix. You're gonna pick A, so 1, then do the inverse of it, times, and then pick B. Oh, did everyone get an error?
Yes.
Okay, then that means that we didn't, okay. So whenever you have the 3 equations like this, because it's x and y, you really only need 2 of them, okay? So we're only gonna, that's tricky. So we're only gonna go through and pick 2 of them. And it doesn't look like any of them are like multiples of the other one, okay? So, yeah, we're just gonna pick 2. So I'm gonna do this one, and then I'm gonna do this one, okay? And I'm gonna enter the matrix for like these 2 only, and see what it gives me. So, and then edit it again, I know, sorry y'all.
So in this case, will we only pick 2 to plug into?
Yeah, so we're only gonna pick 2, because it's given 3 equations, but there's only 2 variables. Okay, so normally you need the number of equations that they're variables. So, yeah, we're just gonna pick 2, because there's only an x and a y.
And technically it doesn't matter which.
It shouldn't, but if we get like something else, we're just gonna pick a different one, okay? So 2 by 2, so it's gonna look like.
You get it with the
What?
you get an answer.
You get an answer?
Yeah.
Okay, sweet. So x, y, so we're not doing something equals -8 and 5. Alright, we get 2, or -1, and then 2. And so this question, number 16, was specifically looking for y, right? Which is the second spot. So which one is that one?
A.
A, yeah. Yeah, or 2. Same thing. Okay.
So
Number-
I have a question. Does it matter which one you drop off? Like, or can you just like?
Like which equation you choose?
Like which
Yeah,
equation you choose.
yeah.
Yeah, so like let's say one of these lines is like it was the thing where it's like the exact same line. You don't want to choose that one because that means like, oh no, you know,
Yeah.
they like that means they're just parallel. So if you get an error with the ones that you choose, go back and just choose a different one.
Okay.
Because it'll still solve it.